Okay, in this question, we're going to tackle what is the speed of the ball after it rolls off of a table. Now, in the first video, we were talking about the fact that when a ball rolls off of the table, its horizontal velocity is separate from its vertical velocity. So as it rolls off the table, it's going to maintain its horizontal velocity. So again, once it leaves the surface of the table, down it goes till it hits the ground. Okay, so when it's approximately right here, it's still traveling with the same velocity horizontally. And here, again, still traveling with the same velocity horizontally. But as it falls from the table, its vertical velocity is getting greater and greater. So our challenge in this question is to find out what the ball's overall speed is, combining its horizontal and its vertical velocity. It sounds really difficult, but it's not. So what we want to look at is, let's see if we can draw the ball again, and we put the ball right here. We want to take this guy here, this velocity, and we want to combine it with its vertical velocity. Well, they chose a time in the problem. It said, what is the speed of the ball after 1 second? Well, the speed of the ball when it rolled off the table was 10 meters per second horizontally. Now we know from other examples that when we drop a ball, it's under the acceleration due to gravity. So that acceleration is 10 meters per second squared, which means that when you drop a ball, after 1 second, it should be traveling at 10 meters per second. Okay? Over the next second, it's going to increase that speed by 10 meters per second. And every subsequent second, it's going to go 10 meters per second faster than it was going previously. So if it's fallen for 1 second, that means that after 1 second, it will be going 10 meters per second squared. Because again, for every second, it was increasing its speed 10 meters per second. So 1 second, 10 meters per second vertically. And it still retains its 10 meters per second horizontally. Now, it may be a little easier if we shift our vectors to where instead of, let's see, let me get another sheet of paper. So instead of them being originating from the ball like that, let's shift this one down to here. And I'll show you why we do that in just a second. But we're going to take this 10 meters per second and then we're going to put it with this 10 meters per second. Okay, so we got 10 meters per second here and we got 10 meters per second here. Now what we want to find is what is the ball's velocity. So we want the resultant of these two velocities. So we're going to draw. Now hopefully you'll begin to see why I shifted that vector down here. Now you may remember, hopefully from high school, that you can find this resultant, this hypotenuse, by squaring these two sides and taking the square root of that. So we're going to say 10 meters per second squared, because we're going to square it because of the Pythagorean theorem, plus 10 meters per second squared, and we're going to take the square root of that, and that's going to give us our hypotenuse. So we'll just call it R. All right. So 10 times 10 is going to be 100 plus 100, because that's 10 times 10 as well. And so that's 200. And that's going to be meters per second. And then we're going to take the square root of 200 meters per second. And that's going to come out to be approximately 14 meters per second. I think it's like probably 14 point something or another. You can do it in your calculator to see what it actually comes out to be, but I think the practice question actually just says, approximately what is it, and it would be 14 meters per second. So once again, we have, let's review real quick. We have its horizontal velocity and its vertical velocity. And because it's rolling off of a table, it's going to follow an arc path. Now, at the 1 second mark, it still has its horizontal and it is increasing in its vertical. So what we want to know is, what is this speed right here? So we combine this horizontal velocity and this vertical velocity, and using the Pythagorean theorem, we come up with this guy right here. So they made it real easy on us, and they said 1 second. So at 1 second, we know that he's traveling vertically at 10 meters per second. And he retains his same horizontal speed that he had, 10 meters per second. So this is one leg of our triangle, this is the other. We pop those values in the Pythagorean theorem. 10 squared plus 10 squared, that's 100 plus 100, take the square root of that, that's 200. That's going to give you approximately 14 meters per second. So that's its overall velocity. When it impacts the ground, it will impact at approximately 14, it's actually 14 point something, but 14 meters per second.